Yeah, hello and good evening. Well, at least it's evening here. My name is Patrick and I would like to demonstrate you the new software PhysicsTracker. And as the name says, actually it tracks physics. So what do I mean by that? Well, it's probably best of all demonstrated, and I will show you this briefly. Let's say you have taken a video of some physics experiment, like for example this one. So let's say we have these two cars, and I've loaded the video now, and you see they collide with a certain speed, and then they retract from each other after the collision. Okay, so now the goal is I would like to analyze the speed during the whole process, and well, first of all I want to see at which location the card was at a certain time, and I can do that using tracking, so computer vision basically. So what I do for that is I create a new mass. Let's call it mass 1, and I mark this mass using this rectangle here, and then I simply click play. And I also defined that I want to track this mass. Okay, now so I want to say that the whole clip ends here, so I can say set stop. So this sets a marker at the end of the track I marked. And well, I could also set a start, but for now I will just start at the beginning of the clip. Okay, so here's the end. Okay, so now we've tracked some frames, and as you can see, that worked nicely in this case. But for this information to be useful, I also need to define some sort of length measure. And from the experiment setup, I know that the distance between two lines here is approximately 1 decimeter. So that's 0.1 meters. Okay, so I can sort of define this length measure using this length measure tool here, and I just mark the distance here using the tool, and then I define it as 0.1 meters. I could also define a coordinate system, and we'll move that to this location. And now everything is set up for analyzing. I could also define the frames per second that the video was taken at, and I can also see here the number of frames is 466, and the clip is approximately 60 seconds in length totally. So given this information, I can now plot the position over time with this tool here. And when I move this slider here, you can see that the point on the graph shows at which location the clip currently is and where the mass was at that time. So what we see down here, that's the time, and you can see the 60 seconds here. And you can also see at which location for the x-axis the card was at the given time. So I can do the same for the y-axis, but not surprisingly in this case it just stays approximately the same over time. And well, I can also show or plot x versus y, and in this sense x would be here on this axis and y is on this axis. Well, I can also plot the velocity and the acceleration, but both is not filtered yet, so I need to put some work into that later. And also I could plot the second mass, which I'm not going to show now for two reasons. The first one is it doesn't really work yet. There's still some problems with two masses because there might be some problems with the filtering. And also you should know how to do it yourself from what I just showed you. Okay, last thing is I could export the collected data to a CSV file, which is pretty simple. I just enter a file name, call it track CS file, save it to my desktop, and then here's the file, and I can just open it with Excel. And as you can see, in this case it didn't really work. That's because I need to define how I want to import it. That's always the problem with CSV files. Yeah, because I basically need to tell the program how the columns are separated. Yeah, so here you see it works. So now you could further analyze the data or even plot it. That's the raw data from the video tracker. And with that, I want to end the video. Okay, thank you for your attention and goodbye.